Here is the derivative of the natural log. So we know natural log is ln of x base e. So before I show you this formula, let me show you a simpler version of this. So the derivative of ln of x is simply 1 over x. That's the derivative of ln of x. Now, if you have ln of a function other than x, for example, a g of x, right? It could be x squared plus 2 or any function but x. So you'll have to multiply by the derivative of the inside. So this is what this is. If you were to rewrite this, this would be using the previous formula, 1 over g of x, because that's the derivative of ln of a function, times the derivative of that function inside. So that's what we have written up here, g prime of x over g of x. Now, this is kind of like a chain rule applied to the natural log. Now, if you don't like that version of this formula, you can also think about it this way as a quick u substitution. So if you have a function ln of u, then the derivative of it is 1 over u times du dx, or simply u prime. Whichever way helps you to understand these formulas. Let me give you a quick derivation to these formulas. So we're going to derive this by simply using the function that we already know, e to the x. So here's a tiny proof of this. So if you consider the function, let's say we want to find the derivative of this function. So if f of x is ln of x, we want to know what is f prime of x. That's what we're trying to derive. Now, the way I'm going to do is by following. So I'm saying let ln of x be equal to y. So by the definition of logarithms, think of it as there is a base e here. So this is really e to the power y equals x. Now I know how to differentiate e, right? We all know by now. So let's do that. So we're going to take the derivative of this function respect to x. So this would be an implicit differentiation. So this is derivative of e to the y, that's e to the y, times y prime or dy dx is equal to the derivative of x, that's simply 1. And we're looking for the derivative that's right here, so I divide both sides by e to the y, I'm sorry. So y prime is equal to 1 over e to the y. Well, we're pretty much done here. Now we just need to substitute. But what is e to the y equal to? Well, e to the y is right here. That's x. Therefore, I substitute that in here. So my derivative is 1 over x. And that's why you see above that the derivative of ln of x is simply 1 over x. Now, to generalize this, we have the formula above. If you have a u, a function of x, then derivative of it is ln of u would be 1 over u times the derivative of the inner function by chain rule. So now let's go ahead and dive into some examples. Let's go ahead and try to find derivatives of these functions. So we'll start with number 1 and then go down the list. So for the first problem, if you want, you can do a u substitution. So let u represent just what's inside the function. So you can use the rule we wrote down above. So if u is representing x squared plus 10, then the derivative of u respect to x using the power rule, this is 2x. Then you rewrite the function in the following way. So your f of x becomes f of u. So it's a function of u where u is a function of x. This is equal to ln of u. So I simply replace u with x squared plus 10. Once I have done that, now I take the derivative. So f prime of u respect to x is simply, so the derivative of ln of u, we know that's 1 over u times the derivative of u. So that's du dx. And then just substituting in what u and du dx is. So u is, we said it's x squared plus 10. That's 1 over x squared plus 10. And du, that's 2x. That's right here. multiply this by 2x. And just rewriting it in a joint fraction, this is 2x over x squared plus 10. So that's the derivative of the function in x variable. Now let's try the next one. Now to find the derivative of this one, we could make the u substitution, but we don't need to because the function here is just simply t, or think of it as x. So the derivative of it is just 1. So instead of making the u substitution, I'll just go ahead and apply the rule. So we're taking the derivative of y respect to t. So the derivative of y is y prime. And here you can differentiate term by term because there is a minus in the middle. So first we take the derivative of the function 3 times ln of t respect to t, and then we're going to subtract the derivative of the function t squared, which is by using power rule. So this is equal to, now here we know that this can be pulled outside the d over dt, so this is simply 3 times the derivative of the function ln of t. And here you can start differentiating that, or just keep rewriting in derivative notation. But I'm going to go ahead and differentiate using power rule. I get 2t. Well, now the question is, what's the derivative of this? And that will finish our problem. The derivative of ln of x, or ln of t, is simply 1 over t. This is 3 times 1 over t minus 2t from before. And putting all of this together, our y prime is equal to 3 over t minus 2t. So a combination of the rule for natural log and power rule. Now let's take a look at the next problem. So our next problem is this one right here. So we're going to take the derivative respect to the x variable in this case. So for this example, we're going to differentiate left side and right side. So when I take the derivative on the left side, I get dy dx, or simply y prime. Let me write that. And on the right side, we take the derivative of each function term by term because of the plus sign. So that will give us the derivative of the function ln of x plus 1. Now I'm going to write it like this. And then plus the derivative of the function e to the x plus 1 squared. And this is equal to, now here you need to use chain rule. So you're differentiating the inner function, which is this right here, ln of x, and then plus 1 to the second power. So by chain rule, we're going to bring down the power, so that's this one right here. So that's 2. You keep the inside, ln of x plus 1. You subtract 1 from the power, that's 1, times the derivative of the inside. So the inside is a composition of ln of x. Derivative of ln of x is 1 over x. And then derivative of 1, that's simply 0. You don't have to put plus 0. I'm writing it just for clarity. So that's the first part. Now the derivative of the second piece, that's also going to be a chain rule. So I'm just going to put the power in here. So again, you bring down the power to keep the inside and subtract 1 from the power times the derivative of the inside. Now the inside is e to the x plus 1. Differentiate each term. So e to the x, derivative is e to the x. Derivative of plus 1, that's 0. And then you just clear things up, but that's pretty much your derivative. So this is equal to, now I can write this as 2 over x ln of x plus 1, and then plus 2 e to the x times e to the x plus 1. So that's my derivative of this function. And now let's do the last problem from our list. That is going to be this one right here. Now, for this one, because it looks like composition of composition, you might want to use a u substitution for this problem. So sometimes you want to, sometimes you don't. It's really up to you. So I'm going to let u to be just this function right here inside the larger ln. So, or the outside ln, right? There's 2 ln in here. So just a little ln of x represent u. Then the derivative of that is simply 1 over x. So let's keep that on the side, rewrite the function. So this is y equals ln of u. We differentiate respect to x. This is y prime. On the right side, 1 over u times du dx. And that's it, we're pretty much done. So plug in u and du, that's from the left side. So this is 1 over u, that's ln of x, times the derivative of the inside, that's 1 over x. So our derivative in a clean form is 1 over x times ln of x. So that's the derivative of this function. I hope this makes sense.